So hello friends, in today's lecture we will see some examples of sequences. Okay, so this for example, here we have one sequence here is equal to Sn such that n term is minus 1 raised to power n. Okay, so we have defined the sequence using n term of the sequence. What is n term here? Minus 1 raised to power n. Okay, so we will try to list the element of the sequence. Okay, so S is equal to sequence. Here n is nothing but natural numbers. Okay, 1, 2 up to so on. So we will get sequence. Put n is equal to 1 first. So minus 1 raised to power 1, which is minus 1. Next, put n is equal to 2. We will get minus 1 raised to power 2. So minus square of minus 1, which is 1. So continuing the process, we will get again minus 1 cube, which is minus 1. Next, fourth power of minus 1, which is 1 up to so on. This is the sequence. S is equal to minus 1, 1, minus 1, 1 up to so on. So we can observe here the element minus 1 is repeating. Similarly, element 1 is repeating. Although this is the sequence, if we have to find range of the sequence, so range of sequences, we know what is range of sequence. We have to collect only distinct element of the sequence. So what are the distinct elements? Only minus 1 and 1. So we define range of sequence in this bracket as minus 1 and 1. So here sequence is infinite, but range of sequence is finite. So understand the difference between sequence and range of sequence. Okay, here range sequence is infinite, but range is finite. Okay. So next example, here sequence is defined as twice n such that n is the natural number. So what is the sequence? S is equal to 2, 4, 6, 8 up to so on. So this is nothing but the sequence of even numbers. Okay, put n is equal to 1, 2 into 1, 2. Put n is equal to 2, we get 2 into 2, 4. Put n is equal to 3, we get 6, 8 up to so on. Now, this is also infinite sequence, and we can observe that every element of this sequence is distinct. So 2 is different, 4 is different. So what is the range of the sequence? Range of the sequence is nothing but the collection of all distinct elements of the sequence. So every element is distinct. So range is 2, 4. The range is 2, 4, 6, 8 up to so on. This is also infinite. So here sequence also infinite, and the range of sequence is this set also infinite. Okay. This is the notation for sequence, and this is the notation for range of the sequence. So now third example, here sequence is defined as first term is S1 is equal to 1 and Sn plus 1 is given in terms of Sn. So we have to find other elements using this formula. So here S1 is equal to 1, put n is equal to 1, we get S1 plus 1, 2. So we have put n is equal to 1. So this becomes 1 plus 1, 2. S2 is equal to 4 times. We have put n is equal to 1 here also. So put n is equal to 1, we get 4 S1 plus 1. What is the value of S1? It is already given. It is 1. So we get S2 is equal to 4 into value of S1 is 1. So 4 into 1 plus 1 is equal to 4 plus 1 is equal to 5. So S2 is equal to 5. S1 is equal to 1. S2 is equal to 5. Similarly, we can find S3, which is equal to S3. Put n is equal to 2. Put n is equal to here also. This S3 is equal to 4 times S2. Since we have put n is equal to here, so 2 plus 1, here S3. Here n is equal to 4 S2 plus 1, which is equal to value of S2 we have already find 5. So 4 into 5 plus 1 is equal to 20 plus 1 is equal to 21. So value of S3 is 21. Okay. So we have find some element of the sequence. So we will list these numbers. So sequence is yes. Okay. First term is 1. Second term we have find out which is 5. Third term is 21, and so on. So this is also an infinite sequence in which every element is distinct. So range of this sequence is what? We have to take every element from this sequence because each element is different. So range of this is equal to the set 1, 5, 21 up to so on. Here both sequence and range both are infinite. Okay. Now we will see one more example of sequence. Okay. So take the sequence t is equal to 1 minus 1 raised to power n upon n such that n belongs to natural number. Okay. This is the sequence. We have to list the elements in this sequence. Okay. So first element is t1. Just put n is equal to 1. So we get t1 is equal to 1 minus 1 raised to power 1 upon 1. What we have done? Just put n is equal to 1. Okay. So this becomes 1 minus. Now minus 1 raised to power odd number, that is minus 1 raised to power 1 is minus 1. So 1 minus 1 upon 1. So which is equal to 1 minus 1 is 2. So 2 by 1 is equal to 2. So the first terms of this sequence is 2. Okay. Now we will try to find second term. For that purpose, we have to put t is equal to 2. So n is equal to 2. Then t2 is equal to, put n is equal to 2. So 1 minus 1 raised to power 2 upon 2. Okay. So which is equal to, so 1 minus, what is the square of minus 1? Plus 1. So 1 minus, this minus, the square of minus 1 is plus 1 upon 2. So 1 minus 1, 0. So 0 upon 2, 0. Second term is 0. Now we will find third term, which is t3. So t3 becomes, again put n is equal to 3 now. So t3 is equal to 1 minus 1 raised to power 3 upon 3, which is equal to 1 minus, what is the cube of minus 1? Minus 1. So 1 minus 1 upon 3. So it's equal to 1 minus 1 is minus plus. So 1 plus 1 upon 3. So 2 by 3. So in this way, we have tried to find the element of this sequence. Okay. So we will write the sequence t. So sequence t is equal to, what is the first element? We have deduced it is 2. What is the second element? It is 0. What is the third element? 2 by 3. So what is the next element? If you put n is equal to 4, this minus 1 raised to power 4 become plus 1. So 1 minus 1, so 1 minus plus 1 become 0. The next term will be 0. What is the next term? So again, see the pattern, 2 by 1, 2 by 3. The next term after 0 will be 2 by 5 and up to so on. So this is the sequence t. Now this is the infinite sequence. And what is the range of the sequence? Take only distinct element from this sequence. So we will get range of t. Okay. Here see 0, 0 is repeating infinite many times. So we have to take only one times in the range. So we can write the range as 0 only one times later on this distinct element. So 0, later on 2, 2 by 3, 2 by 5 up to so on. This is the range of this sequence. This is also infinite set, this is also infinite. Okay. This is the difference between sequence and range of the sequence. Understand? Okay. Now the next point of our syllabus is subsequence. Okay. So we have already know the definition like subset. Okay, so what is subset? Suppose this is the set S is contain the element 1, 2, 3, 4. Okay, so this is subset set S. Okay, so what is subset? Subset is nothing but take some element from this original set S. So we will say suppose S dash is equal to, we take only odd numbers 1 and 3. Okay, this is the subset of S. Subset. Okay, we are not talking about subsequences. This is the one set S 1, 2, 3, 4. So we have done what we have done. We have collected some element from this set. We have taken 1 and 3. So this becomes subset of this set S. Okay. Why? Because 1 belongs to set S and 3 belongs to also set. This is also one set S, but this containing some another superset S. So this becomes subset of this S. Okay. So here S dash is the subset of S. Now if you write P dash, okay, and we have written suppose 1 and 5. So now this is not the subset of S. Why? Because the element 5 does not belong to set S. For P dash to be subset, all the element from this subset must be from the set S. Okay. So now if you write P dash, which is equal to 1, 2. This is also subset of S. Okay. So what is subset? Subset nothing but the set of elements taken from original set. Okay. Now we will see this in the same pattern subsequence. Okay. Now we will see the one example of subsequence first. Then we will go to definition. Okay. So consider the sequence. S is equal to sequence of natural numbers. So 1, 2, 3, 4, 5, 6 up to so on. So this is the sequence of natural number. Now if you write S bar is equal to 2, 4, 6, 8 up to so on. Sequence of even natural numbers. See, every element 2, 4, 6, 8 belongs to the original sequence S, and order also not disturbed. That is 2 is first, 4 is later on. So order also maintained. Then we say this is the subsequence of S. Okay. Also, if you write T bar is equal to 1, 3, 5, 7 up to so on. This is also one subsequence of S. But if you write S1 is equal to 1, okay, 3, 2, 4, 5, 6 up to so on. Now every element in S1 is also belongs to S, but see the order. In this S1 we have taken 3 first and then taken 2, but in this case 2 is first, later on 3 comes, so the order is disturbed here. So we cannot say S1 is the subsequence. So for S1 to be subsequence, order must be the same order. We cannot disturb the order. Okay. So S1 is not the subsequence of the sequence. Yes. Understand? So this is the concept of subsequence. So what is the definition? So let Sn be the sequence and R1, R2, R3 be the strictly increasing sequence. Okay. Such that S bar is defined as SR1, SR2, SRN. This becomes the subsequence. So see, Sn. So we say this Sn is the sequence which contain the 1, 2, 3, 4, 5, 6 element. Okay. Now what they are saying that R1, R2, R3 is the strictly increasing sequence of natural number. See, so this is the S1, this is the S2, this is S3, S4. Okay. So we have taken R1 as 2. So this is the second element, na? So we take R1 is equal to 2. Then R3, we have taken R3 as a this element 4. So 2 is yes R1. So yes, so from sequence we have taken R1 element. So what is our R1? 2. What is our R2? 4. So yes R1, yes R2, yes R3. So we have taken strictly in this sequence of even number. So 2, 4, 6. So from this sequence, yes sir, you have taken yes 2, yes 4, yes 6. Okay. So this become subsequence. So order does not disturb it. Does not get disturbed here. Okay. Order is same. See 2, 4, 6 increasing order. 2, 4, 6 increasing order. Okay. If you write 4 behind 2, then order disturbs. So then yes bar does not become the subsequence. Okay. This is the concept of subsequence. And this yes bar also a sequence, but it continuation. So we say this yes bar is subsequence of this sequence. Okay. So now you will see another example of subsequence. So we have given a sequence whose n term is 1 by n. So we can write this sequence as 1, 1 by 2, 1 by 3 by just putting n is equal to 1, 2, 3 up to so on. We will get our sequence. Now we define s bar is equal to 1, 1 by 3, 1 by 5 up to somewhere 1 upon twice n minus 1 up to so on. So what we have done, we have just take first term, then third term, then fifth term. Okay. So we have taken a subsequence. It's also infinite. Order sequence also infinite. So this is the subsequence of this sequence. Why? Every element in this subsequence is already in yes. Also, we don't disturb the order of the elements. So this is the subsequence of this sequence. We can also write this in the sequence 1 upon twice n minus 1, such that n belongs to this is the subsequence of this sequence. Okay. So another subsequence write is as yes double bar is equal to just take terms elements at the even position. This is second position, fourth position up to so on. So yes double bar is equal to 1 by 2, 1 by 4, 1 by 6 up to so on. It's nothing but the sequence 1 upon twice n such that n belongs to natural number. This is also subsequence of this sequence. Why? Every element here are already continuing yes, and order of element also same. Okay, or we don't disturb the order of the elements. Okay, but if you take s dash which is equal to 1 by 2, 1 later on 1 by 3, 1 by 4 up to so on. Now this is not a subsequence. Why? Here we have written 1 by 2 before 1, but actually in the sequence 1 by 2 comes later 1. Here order get disturbed. So this is not the subsequence of this sequence. Although all the elements here are already continuous, but here order get disturbed. This is not the subsequence. Okay. Also, yes double dash given by 1 by 2, 1 by 6, 1 by 4, 1 by 8 up to so on. This is also not a subsequence. Why? Here order get disturbed. If 1 by 4 is written before 1 by 6, then it becomes subsequence. Okay. So this is the one more example of subsequence. Okay. Now here this is sequence of cube of natural numbers. Now to find a sequence, subsequence, what we have to do? Just delete some elements and maintain the order. We get subsequence. For example, we delete or we omit the cubes of odd numbers and only write the cubes of even numbers. So suppose s bar is equal to, we have to take only cubes of even numbers. So 2 cubes. 4 cube, 6 cube, up to so on. This is the subsequence of sequence. Yes, why? We have taken elements from yes, and order is the order does not get disturbed. Okay, we have maintained the order of the element. It is increasing order is maintained. Okay. Similarly, yes double bar, which is given by 1 cube, 3 cube, 5 cube, is also subsequence of this sequence. Okay. Why? Every element here is in yes, and order of the element is maintained as in the original sequence. This is also example of subsequence. Okay. Now we can add another subsequence as just delete some numbers and maintain the order. So what we do? We delete these two numbers and write the original sequence as it is. Okay. So we start from 3 cube, then 4 cube, then 5 cube, up to so on. This is also subsequence of yes, but all the elements are taken from original sequence and the order of elements is maintained. Okay. So this is also subsequence of this original sequence. Understand? So the next point is constant sequence. So what is constant sequence? We get idea from heading only. Okay. What is constant means? A fixed number. For example, take sequence yes is equal to 1 1 1 1 1. See, every element is fixed, that is constant 1 1 1 1. Such sequence are called constant sequence. So what is definition? The sequence say x such that all of whose terms are same or equal, that is constant, like 1 1 1 1, that is x up to so on. So all of whose terms are equal to fixed number x belongs to R. Such a sequence is called constant sequence. For example, s is equal to sequence constant sequence 1 1 1. Then we can add this sequence also as only s is equal to 1. Okay, means every term is 1. Also, another example is 0 sequence. That is each term is equal to 0. So 0 0 0 up to so on. Such a sequence are called constant sequence. Okay. Now the next term is bounded sequence. Okay. Our next point is next special sequence is bounded sequences. Bounded sequence. So also again we get idea from the name bounded. Okay. What is mean? That is sequence has some bound. For example, now consider the sequence yes given by 1 by n such that n belongs to natural number. What are the element of this sequence? The element of this sequence are 1. Just put n is equal to 1, 2 up to so on. Suppose n is equal to 1 by 1, 1. Put n is equal to 2, we get 1 by 2. Later on 1 by 3, 1 by 4, 1 by 5, somewhere 1 by n, 1 upon n plus 1 up to so on. These are the elements of this sequence. Okay. Now see, the first term of the sequence is 1. Later on 1 by 2, 1 by 3. So if we observe the element of the sequence, 1 is the highest element of the sequence, because 1 by 2 is less than 1, 1 by 3 even less than 1 by 2, so we are also less than 1. So each term as we go right, every term is less than its previous term. So in this sequence the element 1 is the highest. So there is no element in this sequence which is greater than 1. So we can say 1 is the upper bound of the sequence. Okay. Also, any number greater than 1 is also the upper bound for the sequence. But 1 is the least. So we call this least upper bound. Okay. Again, if you see pattern, the sequence 1, 1 by 2, 1 by 3, 1 by 5, as n tends to infinity. Where is sequence going? As n tends to infinity, the elements are going. So denominator is going increase. So as n tends to infinity, 1 by n tends to 0. The sequence is tending to 0, and so there is no point which is also less than 0. So this sequence tends to 0. Okay. So see graphically. So this is the point 0. This is 1. So first point of this sequence is 1. Second element is 1 by 2. Third element is 1 by 3. Then 1 by 4. So continuing this way, we are tending to 0. So as with n tends to infinity, elements are going closer and closer to 0. So 0 is the lower bound of this sequence. Okay. So when sequence is bounded, it has upper bound and lower bound. Now we will see the actual definition of bounded sequence. So first we will see a sequence Sn is said to be bounded above. Okay, a sequence Sn is said to be bounded above if there exists a real number capital H such that each term of that sequence is always less equal that number. So when every element of sequence that Sn any term, take any term, and if which is less equal some fixed number H, then we say that H is the upper bound of sequence, and this sequence is said to be bounded above. See, a sequence is said to be bounded above if there exists a real number H such that Sn is less equal H for all n belongs to n. Then we said the sequence is bounded above and the number H is called upper bound of the sequence. Okay, that is, we have already seen this is the sequence 1, 1 by 2, 1 by 3, 1 by 4 up to so on. But we have seen that this is the first element of the sequence, this is second, and other elements are here. Okay, here we have seen that every element of the sequence take 1, 1 by 2, 1 by 3, 1 by 4. Okay, are always less equal 1. That is, here H is, we can take H equal to 1. Why? Because take any term, it's always less equal 1 here. See now, the 1 is less equal 1, 1 by 2 is less equal 1, 1 by 3 is less equal 1, 1 by 4 is less equal 1. So here 1 is upper bound of the sequence. Similarly, 2 is also upper bound of the sequence. Why? Take this term 1 which is less equal 2, 1 by 2 less equal 2, all the terms are less equal 2. So 1, 2, 1.5, all these elements we can say are the upper bound for this sequence. Okay, so this is the sequence which is bounded above, and these are the upper bounds. One is upper bound, 1.5, 1.2, 2, 3, 4 up to so on are the upper bound for the sequence. Only one point is here that though 1, 2, 1.5, here 3 are the upper bound. So among this upper bound, one is the least. So there is one more term that least upper bound. So 1 is the upper bound and also least upper bound. We say LUB. Okay. A sequence Sn is said to be bounded below if there is a real number H such that each term of this sequence is always greater or equal that number. Then we say that this small h is a lower bound of the sequence. Okay. For example, here we take the same example. Okay. This is the first element of the sequence is 1. Second element of this sequence is 1 by 2. Then 1 by 3 up to so on. We know this as we continue with this sequence tends to 0 but cannot go beyond 0. Here see each element of the sequence is always greater equal some number and that number is 0. See, every element of the sequence is right side is on the right side of 0, that is greater equal to 0. So 0 is one of the lower bound for this sequence. So this sequence also bounded below. Why? There is number 0 such that each element of the sequence is always greater or equal 0. Okay. So this sequence is bounded above and upper bound is one of the upper bound is 1. This sequence is bounded below, one of the lower bound is 0. And we can say also, so this is 0 and this is minus 1. This is minus 0.5. Also minus 0.5 also lower bound. Why? Each term of the sequence is always greater or equal minus 0.5. Similarly, each term of the sequence, these terms are also greater or equal minus 1. So minus 1 also a lower bound. But actually every element on this negative axis is the lower bound for this sequence. Okay. Now among it, of all these lower bounds, 0 is the greatest. Okay. 0 is greater than minus 0.5, which is greater than minus 0.5 is greater than minus 1. So among these numbers, 0 is the greatest. So we say that, and it is lower bound. So there is term greatest lower bound. So 0 is the lower bound and also greatest lower bound. This number is only lower bound. This number is also lower bound, but 0 is a lower bound, but greatest among all lower bound. So it is the greatest lower bound. Also, for this sequence, 1 is the upper bound. Why? There is no element in the sequence which is greater than 1. Okay. So 1 is the upper bound. Similarly, 1.2, 1.3, 1.5, 2, 3, all these numbers also are upper bound for this sequence. Why? Each term from this sequence, each element of this sequence is always less equal 1. So always less equal to 2.5 up to so on. So each element from right side to the 1 is the upper bound for this sequence. But among all these upper bounds, all these are upper bound. 1 is the lowest or least. So 1 is the least upper bound of the sequence. Okay, understand the concept? We will see more examples regarding the bounded sequence. And the term is, definition is, a sequence is said to be bounded if it is bounded both above and below. Okay. For example, this sequence, it is bounded above, upper bound is 1, bounded below, lower bound is 0. This sequence is said to be bounded. So bounded sequence means a sequence which is bounded above and bounded below. Okay. So we will see more examples later on.